So for this question we've got to try and work out the rate equation. So rate equals K, which is the rate constant, multiplied by the concentration of A raised to a power. The power that A is raised to, the number that it's raised to, is called the order with respect to A. So rate equals K, concentration of A to some power, and then multiplied by B, the concentration of B to a power, and the power of B is the order with respect to B. How do I do that? Well, first of all, I'll look at two experiments where either A or B are the same. So I can see in experiment 1, B has a concentration of 0.26. In experiment 2, B has a concentration of 0.26. So I'm going to choose experiments 1 and 2, and you'll see why in a minute. Because those two are the same, for B, it's going to make life easier. What do? I take the concentration of A in experiment 2 and divide by the concentration of A in experiment 1, and that will be to the power that A is raised to in the rate equation, the order with respect to A. I do the same for B, raised to the power that B is in the rate equation, order with respect to B, and I take the rate 1.89 times 10 to the minus 3 and divide by 2.1 times 10 to the minus 4. Let's see that. 0.36, and I've put to the question mark, that's going to be the order with respect to A, so rate equals A to the question mark, 0.36 divided by 0.12 to the power question mark, where the question mark is the order with respect to A. Multiplied by 0.26, so the concentration of B in experiment 2 divided by the concentration of B in experiment 1, 0.26 divided by 0.26, and that's going to be to the power of B. But it won't really matter because that's going to cancel. Equals 1.89 times 10 to the minus 3, so the rate in experiment 2 divided by the rate in experiment 1. So this cancels. 0.36 to the question mark divided by 0.12. 0.36 divided by 0.12 is 3, so 3 to the question mark equals, do this calculation, equals 9. Now that question mark there, the order with respect to A, 3 squared equals 9. So the question mark here is a 2. 3 to the power 2 is 9, that question mark there is a 2. So rate equals A, concentration of A to the power 2. These numbers here, by the way, the orders with respect to A and B can only ever be noughts, ones or twos. So 3 squared equals 9, that's a 2. Next, I'm going to have to choose the other two experiments to be able to work out the order with respect to B. We've got spoilers. I'm telling you it's a 1, so let's see if we can work out why it's a 1. In these two experiments, I've not got any concentrations the same in either experiment 2 or 3. But it's not so bad this time because I've already got some information from my first calculation. My next two experiments, 0.72, so I'm going concentration of A in experiment 3, divided by the concentration of A in experiment 2, 0.72 divided by 0.36, raised to the power 2, and know that's a 2 because it's a 2 here, multiplied by concentration of B in experiment 3 divided by concentration of B in experiment 2, 0.13 divided by 0.26, and that question mark there is this number, the order with respect to B, equals 3.78 times 10 to the minus 3 divided by 1.89 times 10 to the minus 3, and if you calculate that, this number here is a 2. 2 squared multiplied by, this is a half, 0.5, 0.5 to the question mark. Remember this question mark is this number here that I'm trying to find out, the order with respect to B, equals, these two numbers divided equal a 2. 2 squared is 4. 4 multiplied by 0.5 to the power question mark equals 2. 2 divided by 4, so if we take this across the equal sign and down to the bottom, 2 divided by 4 is 0.5. So 0.5 to the question mark equals 0.5. It's itself. 0.5 to the question mark equals 0.5. Something that's itself means that's to the power 1. So order with respect to b is a 1. Incidentally, if something turns out to be a 1 here, so if, say for example 0.5 to the question mark equals 1, the question mark is 0. Any number to the power 0 is a 1.